In our grade 2, we have a question that says, of the following derived units, the one that is not a unit of power is. Now in this question, we have to look at the options and find out the odd one out. That means the one that does not have the unit of power. And before we can know the one that does not have the unit of power, we need to know all the units of power. Okay, so what is power? There are two basic formulas for power. The very first formula is found in our mechanism, which is power equals to work over time. And the other one is found in electricity, which is power equals to current, which is I, multiplied by your voltage, which is V. So with these two formulas, you can be able to derive all the whole units we have in power. Starting with the very first one, which is our mechanism. In mechanism, we see that power is equals to work over time. And the unit for work is called joule, and the unit for power and time rather is called second. So we can say power can be joule per second. Let's keep this as our very first unit. And the other kind of unit we can also derive from this our power, which is under mechanism, is when we try to break down the units for work. You know, work is force times distance all over time. And the unit for force is in Newton multiplied by your distance, which is in meter, all over the time, which is in seconds. So we can say that another unit for power is Newton meter per seconds. This is the second unit for power. So these are the major two units we can derive from mechanism for power. Now let's check the other one, which is electricity. Now when we come down to the formula for power, under electricity, we have that power is current times voltage, where your I represents the current and your V represents the voltage. Your I, which is in current, has a unit we call ampere, while your voltage, which is V, has a unit we call volt. So I can literally say that power is equal to ampere volts. Ampere volts. So this is the third unit for power. Let's call this our number 3. Let's move on. There is a law in electricity we call the Ohm's law. Ohm's law says V is equal to I R. So that means my voltage can be represented as I R. So if my voltage is represented as I R, coming down to the formula I have for power, that says P is equal to IV, where I have my voltage, I can substitute it for I R. When I do that, I have that I in the bracket of I R. So what do I have at the long run? On the long run, I have it as I squared R, where my I is in ampere, so I will say I is ampere squared. Let me put it in short form like this. Then my unit for resistance, which is R, is ohms. So this is the fourth unit for power. Now let's try the other way around. Since we already had that our V from Ohm's law okay, sorry for that, from Ohm's law, where the V equals to IR, I can also try to make use of my current as the formula. So I will say I is equal to V all over R. Now that I have that my current is equal to V all over R, so therefore I have the power, which is equal to IV. Any place I have the value of my current, I'm going to use V over R. So let's input that. I have that V all over R in the bracket of V because of the V. Now when you do that, we are going to have our answer to be V squared over R. Now when we look at it carefully, we see that we have the units for voltage to be volts squared all over our resistance should be ohms. So this is the fourth unit of power. Now let's write out all this formula and see the one that is not there in the option. So considering the formula we have for power and our unit, the very first one we have was joule per second, the other one is Newton meter per second, another one is ampere volt, another one is ampere square volt, and the last one we had is volt square ohms. Also have it in mind that power generally is equals to watt. That's the general unit for power. But we are not considering watt. So let's look at the option, which of them is the odd one out. So you look at our option, do we have joule per second? Yes, we have joule per second. Do we have ampere volt? We have ampere volt. Do we have ampere square volt? We have ampere square volt. Do we have ohm square volt? We don't have ohm square volt. We only have volt square ohms.